In this warm-up, you are converting the units. So you may need to pull up another tab if you're not sure about unit conversions.
For example, in problem 6, you have 60 miles per hour, but there are 5,280 feet per mile, so we would have 60 times 5,280 to tell us how many feet per hour they can go, which is 3.16800, but that's per hour. So if we want to figure out how many seconds, well, there are 60 minutes in an hour and 60 seconds in a minute. So that would be 3.16800 divided by 60 to turn it into minutes, and then divided by 60 again to turn it into seconds. No, times 60. No, divided by 60. And that is 88 feet per second. So you can use that 5,280 to convert feet to miles. You would divide, because there's less than 1 mile here, so we would divide by 5,280. For feet per minute, to change to feet per second, we would divide by 60, because there are 60 seconds in a minute. 2 miles times 5,280 would tell you how many feet. 3 hours, you would multiply by 60 and 60 again to turn it into seconds. To turn seconds back into hours, we would divide by 60 2 times. So complete that warm-up before moving on. You can pause here if you need to. Suppose you go to an amusement park for a field trip. This is a map of one section of the park. The amusement park is closing soon, and we want to go on more rides. Which rides can we go on? Can we get to all the rides in the park before it closes? Today we're going to use the Pythagorean theorem to support our answer to questions like these. You will need to turn in your book to page 333, where you can see the amusement park map on a grid. It should look something like this in your book. And it does have a bit of a legend or a scale on here telling you that each box is 10 feet wide. So that's going to be some important information moving forward. What might impact how long a path would take? Do you think that the longest amount of time is going to be walking between the rides or waiting for the ride? What is the most efficient path you could take between any 2 rides? Which paths are direct paths from one ride to another? Will the order of the ride matter? So these are some things to consider as we move on into solving our problems. Here are your goals or your criteria. It says suppose you have 1 hour and 30 minutes left until closing time to explore the rides at this section of the amusement park. Starting at the entrance, use the map to determine a path you can take to ride any 4 rides and make it back to the entrance by closing time. Here are your guidelines. You cannot repeat a ride, and you run between rides at 5 miles per hour. So it says sketch your path on the map, which is on page 333. Think about how long it takes you to make it back to the entrance, and do you have extra time before the park closes? If so, how much? Here's another piece of helpful information. You might want to consider how long the wait times are for these rides when determining which rides to go on. For example, the roller coaster, you're going to have to stand in line for 30 minutes. That's a long time when all you have is an hour and a half left. So maybe you prioritize some of the rides that have shorter wait times. So looking at this list of ride times, I don't want to take 30 minutes to wait for a roller coaster. And I do not want to take 25 minutes to wait for a flume ride, or 20 minutes to wait for bumper cars. So I'm going to ride the 4 shortest wait times. Remember, we can't repeat any rides, but we need to ride 4. So there's 1, 2, 3, 4. Now, I have to think about the path I take. Do I go straight from the entrance to the carousel and then over to the teacups? Do I go to the swings first and then to the race cars, the carousel, the teacups, and back? We have to think about the different paths that we can take. Now, I can't go straight from here to the swings because I would run into what looks like a planter. So I do have to go out and around, but I think that's still going to be faster than skipping and coming back. We'll see. So I'm going to draw some lines in here using a straight edge. If you have a ruler, that would be helpful. Okay, so to get to the swings, alright, now I'm going to also keep track of how many feet this is to help me with my calculations about how fast I get from one place to the next. So this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 10 and 17. So that's a total of 27 boxes. And we'll come back to this 10 feet later. We'll multiply by 10 in the end. Okay, so that takes care of my swings. Now, is it faster to get to the teacups, the race cars, the carousel? It looks like it's going to be faster to get to the race cars. Now, I'm going to take a direct route this time, since there are no trees or bushes or anything in the way. But this is a diagonal, so I'm going to use Pythagorean theorem to help me figure out how long that diagonal is. Creating a right triangle here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 boxes. And 1, 2, 3, 4, 5, 6, 7, 8. So this is traveling to the race cars. We would have 11 squared plus 8 squared equals c squared. 121 plus 64 would be 185. So traveling to the race cars is the square root of 185. Remember, we will multiply by 10 in the end. Okay, then from the race cars, we're going to go to the carousel. Again, we'll need a right triangle since that's cutting at a diagonal. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So to the carousel. Five squared is 25. 25 times 25 is, let's see, 625. If we add those together, that gives us 650. And I don't think that is a perfect square, so we can leave it in terms of a square root. Now up and over to the teacups for our final ride. Doesn't look like anything's in the way this time, so we will take the direct path. Creating another right triangle. This is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And this is to the teacups. We have 7 squared and 15 squared. 7 squared is 49. 15 squared is 225. Plus 49 is 274, which again is not a perfect square, so we'll leave that as the square root of 274. And then finally we need to get back to the entrance. Can we take a direct path without cutting into the bushes? Yes, and it looks like we'll also steer clear of that little table with the umbrella. Okay. This is going to create another right triangle on this one to calculate the length of that diagonal. Alright, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is going to say to the entrance. we had 33 and 15. 33 squared is 1,089. 15 squared is 225. So we'll add those together. Is 1,314. My guess is that's not a perfect square. So that would be the square root of 1,314. Okay, so that takes up just the travel time. We need to calculate, if they go at a rate of 5 miles per hour, we need to calculate how far this is in feet. So we have 5 miles per hour. Well, we know 5 miles we can multiply by 5,280, and that will turn it into feet. So this is 26,400 feet per hour. But we want minutes because we need an hour and a half, so 90 minutes total is how long we have. So if we want feet per hour, we need to change that into minutes. So we will divide by 60 to get the minutes. And that is 440 feet per minute. Okay, now we need to figure out how many feet this is. So we're going to add all of these up. And we can do that on our calculator using those square root symbols. So here is mine. I got 27 was a whole number. The square root of 185. The square root of 650, square root of 274, the square root of 1,314. But keep in mind, all of this is 10 feet. You can see here the 10 feet, so we have to multiply it by 10 in the end. So this is 118.89, but we need to multiply by 10. So this is really 1,188.97. 99. So now we need to figure out how long that takes. If they can go 440 feet per minute, well, we need 1,188.99 divided by 440 to tell us how many minutes it takes them to travel. So I'm going to leave that whole value in my calculator from before and divide by 440 so I don't get any round off error. But don't forget I have 10 times that amount, so actually it should say 2.70 minutes. So very short amount of time comes from actually traveling between them. The most amount of time is going to be us waiting in line for these rides and the actual ride times. So this is to run around the park. And now we'll need to calculate how much time altogether. So this is for the carousel. We've got 2.70 plus the 10 for the waiting in line and the 2 minutes for actually riding the ride. The race car, we've got 15 minutes waiting in line and 5 minutes riding the ride. 18 minutes waiting in line for the swings, and this is 1.5 minutes. The teacups, we've got 8 standing in line and 2 minutes riding the ride. Remember, our total should come out to no more than 90 because we have an hour and 30 minutes. which is 90 minutes altogether. So when we added all these together, we got 64.2. The question also asked us how much time would be left over, so we knew we needed 90 minutes until the part closed. So we do have some time left over since we haven't quite reached all 90 minutes. So to figure out how much is left over, we're going to subtract 64.2 from 90, and we have 25.8 additional minutes. Make sure your lesson is filled in today. If you used a different path on your amusement park, make sure that your problems match the work that you did on page 333.